Good morning. Thank you for joining me today. My name is Charles, and I work as a laboratory assistant with Dr. Arthur Holly Compton. During our X-ray scattering experiment in 2022 at Washington University in St. Louis, our team wanted to answer a very important question. Does light behave only as a wave, or does it also behave like a particle? Today, I'll answer a few questions about our work and explain why this experiment became one of the most important discoveries in modern physics. First, let me tell you about our project. Excuse me. So, our project, I had worked with Dr. Arthur Holly Compton on the Compton X-ray scattering experiment, where he directed X-rays at electrons and measured what happened after the collision. Our goal is to understand the true nature of light. So that was our whole purpose of it. So many of you want to know what we're trying to discover. So we wanted to know whether X-rays behaved only like waves or whether they also behave like particles. So after measuring the scattered X-rays, we found that their wavelength became longer after striking electrons. This proved that light transfers energy and momentum like particles called photons, as you know. So, and then the third question to all of you guys, where did the experiment take place? So, our experiment took place, as I said, in Washington University in St. Louis, Missouri. We used an X-ray source, graphite, and special detectors to carefully measure the scattered radiation. And then, so looking at about what happened in the world, a discovery happened in 1922 and was published in 1923. The world recovered from the World War, back when radio broadcasting became popular, and scientists were making exciting discoveries about atoms and quantum physics. So, who else worked on the project? The project was led by Dr. Arthur Compton. Other researchers and laboratory assistants helped collect data and repeat the experiment. Our work also built upon Albert Einstein's early idea that light is made of particles called photons. So, what was my role in all of this? I helped prepare the equipment, record measurements, and compare our results with our predictions. We repeated the experiment many times to make sure our results were correct. So, through all of that, the most impact that my project had would be that our experiment provided strong evidence that light behaves like particles as well as waves. Discovery became one of the foundations of quantum mechanics. Dr. Compton received the Nobel Prize in Physics in 1927 for this work. Today, the Compton effect is used in medical imaging, radiation therapy, astronomy, and nuclear physics. So many things going on today. So it was very, very useful and had a very big impact in physics today. So the hardest part of the experiment, I would say, the hardest part was measuring extremely small changes in the wavelength of the scattered X-rays. You have to be very close, pay attention. You have to very make sure you're not missing out. And our experiment had to be extremely accurate. And we repeated the experiment multiple times before we were confident in our results. So thank you for listening for me today. I hope this interview helped explain why the Compton X-ray scattering experiment changed physics and helped scientists better understand the nature of light. Thank you, and I hope you guys join us for another interview some other day.